we have John Bowey here, and he is a skilled documentary filmmaker. I'm pleased to introduce him and his work, The Climate Restorers, and that's a documentary displaying all the climate restoration work being done around the world. So I don't want to steal his thunder. Please take it away, John. Let's help me welcome him.
Great. Okay. Thanks, everyone, for staying. And it's a tough act to follow. There's been some really eloquent speakers talking about some really interesting stuff. So I'm not a scientist. I'm not a person that works with the environment, but I've been working on a project due to my marriage, my scientist wife, and I got pulled into getting to know about the project. But the title of this story that I'm going to share a little bit, which is kind of about my journey in terms of making a film about the climate from the perspective of someone that knew nothing about it. I may know less now than I did before, actually. I certainly got a lot more questions. But the title, Being Right Isn't Enough, it's kind of provocative on purpose, but it is something that I experienced in terms of working on the project and connecting with a lot of different people, because there was a lot of positionality and a lot of people were right in terms of the work that they were doing. It was accurate, it was true, it was right. But it kind of limited the possibilities of collaboration, I think. And that was one thing that I took away. That's my mind. Yeah. Okay. I've worked on a lot of different projects, interesting social things. I've done immersive experiences in the Middle East and Saudi Arabia. I've done talk shows on subjects. I've tutored presidents in Africa. I've made lots of horror movies. I've directed live concerts with groups like U2 and stuff. And I traveled with the Dalai Lama, hoping that I won't come back as a cockroach in my next life. No, seriously. But yeah, I'm a filmmaker to a degree. And how many people here are filmmakers? Okay, that's more than I expected. Actually, that's great. But how many people have mobile phones and post on social media? And so everyone's a filmmaker, really. And I think that's the world that we live in now. And filmmaking or sharing stories and sharing images is such an important aspect of life, and it can be used for good, and quite often it's not used for good, and it creates additional challenges. So anyway, when I started looking at how I put this together, this project, what would be the elements in it that I would need to do? And it's nice to put. I've got a cute animal there, because cute animals get really high viewing rates on social media. So if you've got some scientific data and you want to get some good viewing, then put a cute fox on there. But obviously it goes a lot deeper than that. And so I started to think about what are some of the recurring messages that have gone throughout time, because as we've been storytellers from the beginning of history and before then, probably. And one thing I noticed was that throughout time and culture, there's always been this story about a guy that's running around frenetically telling everyone that something bad's going to happen. There's a pending catastrophe on the horizon. And nobody really listens to that person, and then the catastrophe happens. It's a real mess, and then we have to clean up afterwards. And we carry that forward, and Noah, obviously, from the Bible, Napsaptich, forgive my pronunciation, but this guy, which was part of the saga of Gilgamesh. In terms of Hindu, there was Manu and the flood. In terms of Greek mythology, Deucalion. And then in native North American culture, the Cree and the Menominee, talking about the Onteki bringing a great flood. So it's something that we've carried through with us through the ages. And what we've done now is contemporize that story with blockbuster disaster movies. I mean, we start off with kids telling them fairy tales, which are quite violent, that some guy's going to come along with an axe or leave you in the forest to deal with yourself. So we're kind of predisposed to catastrophe, I think, and it's kind of in our DNA. And so, ironically, we spend billions making these horror movies, disaster movies, and we spend billions watching them. If we could take those budgets and put that towards the real disaster movie, which is going on a daily basis, then I think we'd be ahead of the games. But it's in our nature. It's a recurring message that goes through things. So the majority of us, just as we become immune to, and it's terrible, I was talking to one of the ladies from Ukraine, and we've become almost immune to the disaster that we see and the carnage that we're seeing there every day. And we've equally become immune to the news that we see of catastrophes, floods and all the rest of it. It's just, and then the sports results and then something else. It's just part of the diet, the media diet that we have. So how do we address that? And how do we address a new generation of people where, their parents, the boomers and the ones before them have done all these things. They've been petrol heads. They've had V12 cars, V8 cars doing donuts and stuff. And now we mustn't do that anymore. And it's like, who are you to tell me to do that? And I don't think it's articulated that way, but I think it's a significant point. So I think putting a film together about a climate story and about a positive climate story, I think it's a love story, it's an adventure, it's a detective story. These are shots from stuff that we were filming, actually. It's certainly a mystery. But why doesn't the science hold? Another thing I noticed when I was looking at putting the project together was that the relationship between science and the church wasn't that great. I mean, I think in Islam it was good because they were using science and astronomy and navigation and doing a lot of constructive things. But generally speaking, you had a high risk of getting burnt in Christianity if you had a heliocentric view of the world and stuff. But just after Galileo, who was lucky because he had good contacts in high places, he didn't get burnt. He got his wrist slapped for humiliating the church more than the science. It was more about him humiliating them. And a relationship was developed between science and the church. We'll look after the souls if you guys, deal with the rest of the stuff. And now that kind of relationship now has been taken over, I think, between science and then we have industry and profit. And although there's a lot of common benefit, there's still a broad line drawn between there, and that's the new battle lines that we face. So again, how do we address those things without continuing the polarity that we're living with at the moment? How do we come up with a kind of lexicon that doesn't have trigger words in it, and everything's going great until you say that one word that they disagree with, and then the doors come down, it shuts, and they're not really interested in listening to anything else. So, for me, I didn't know much about the climate other than the fact that we were doing things that we shouldn't do, and I got on with my job making horror movies or doing the other things until I met Phoebe, and then I changed. Kind of. But from what I knew, the only thing that was possible was to reduce emissions. That didn't seem to be happening. So I'll just get on with my job and imagine that things will get hotter and stuff. But I didn't know what the future really held. And then through Phoebe, I met Peter, who I'm sure you've heard quite a bit about Peter's book, Climate Restoration. Peter has plenty of marketing on this. It's a great book, and it changed my view on things because it offered an alternative to me, that there was a possibility. And I know it's a no-brainer, but the idea that we've got to keep reducing something, and otherwise we're in deep shit. But the fact that we could actually consider removing stuff from the historic carbon that's been building up, when you hear it, it's a no-brainer, but when you haven't heard that, you were just in the position that I was probably in. So we talked about putting a film together, a short film, And then we did the really smart thing of turning it into 4 films. And the reason that we did that was because I've seen some really good films on climate, but they're so dense that by the time I walk out of the movie theater or wherever it is, I've seen it, that information's already started to evaporate. And the importance of films like this is to be able to share that information to somebody else and then pass it on, as opposed to saying, it was really cool and they set fire to some methane bubbles in the ice, and I don't remember what else there was, but there was. Anyway, it was really cool. And so how do we overcome those communication challenges? So we decided to make 4 films, The Climate Restorers. So 4-part series, 4 one-hour films, and they ranged from the first one on methane, one on blue carbon, one on the built environment, and one on ecosystem restorations. Now, as far as the methane film is concerned, and you've all heard from people that know a lot more than I do about methane, but it's kind of the low-hanging fruit, really, because it's got a short lifespan. What we do to methane now can have a significant effect, and it could possibly, if we got our act together, we could at least slow warming down by up to about a third of a degree, I think it is. I can't remember. But it's significant. It's got a couple of anomalies, because over a 20-year period, it's 86 times more powerful than CO2. So even just converting methane into carbon dioxide and water, I guess, you're ahead of the game just by doing that, although it seems a little bit counterintuitive. In terms of what's going on, because we traveled all over the world, we went up to Alaska, where there's major methane challenges there with the thawing of the permafrost. And we met with a lady called Katie Walter Anthony, who's a methane scientist. And human-made emissions of methane take up 60%, but natural-based are about 40%. But because we're warming the planet so much, the concern is that the nature-based amount, 40%, is going to shoot right up and overtake the human emissions of methane, which would be disastrous. So where you can see Katie there, behind her is a Thermokarst lake. That wasn't a lake 10 years ago. It was just thawing permafrost. It melts, it gets soggy, the trees collapse into it, the water expands. The water temperature itself accelerates the rate of methane, it accelerates the amount of methane coming up, because all the biological materials, the vegetation's rotting and releasing methane in large amounts. There's Katie heading off to actually set fire to some methane to show us, and we put that on the show. It's a kind of a parlor trick, I guess, but it does bring it into strong, visible terms what's actually going on, that you can just collect bubbles and it's highly inflammable. It's methane. It gets even worse than that, because in part of the ponds, it's almost like a jacuzzi. Now, generally speaking, with the climate warming, you've got areas where the permafrost is affecting the first 1.5 feet or 2 feet, but then it freezes again in the winter and then thaws again. And that's obviously a real problem in itself. But you've got these chimneys that are going down 400 feet in some cases and connecting with fossil methane. And you end up with this. It's like a jacuzzi, and it's methane just pouring out. They don't know how that happens, why it happens. They're working on that. But we show that as well, just to bring home the truth. We then went down into a tunnel, which was dug by the Army Corps of Engineers, and it was for the US military to look at how permafrost is changing. I guess just the idea that in Ukraine, for example, I mean, in terms of moving heavy artillery in the winter, you can't do that in January. You can't do that in April, where the ground is melting, thawing, and then your vehicles get stuck. A lot of other reasons that they were doing that as well, but that was the initial idea, and also looking at tunneling methods for hiding weaponry and stuff like that. But while we were down there, it was like an Aladdin's cave of stuff. This area that we were in is all about 43 to 45,000 years old, so there's mammoth bones sticking out the walls. There's this is an underground glacier, basically, and this really brought it home, because This is the stuff that melts, and then all of a sudden the ground gives way. You look at a lot of roads in Alaska, and they're curved and undulating because of the temperature change and basically just giving way. So what are the solutions in terms of what we can do? And we connected with a company in Copenhagen, Matthew Stanley Johnson. He's a top methane scientist, and he's working on methane oxidation. And in real simple terms, in my terms, basically, and it also applies to ocean ion fertilization, funnily enough, but where you've got these clouds of dust coming off the Sahara, for example, they travel from a northeast down to southwest, crossing the Atlantic, creating hurricanes and different things with the air temperature. But they're dropping iron on their way, and that also helps ocean ion fertilization. But when that iron crosses into the ocean boundary, which is, I don't know how many feet above the ground, but you've got the chlorine from sodium chloride from the sea spray and stuff reacts, and you get a process basically that breaks down the methane. And so they discovered that, and then what they're working on is to replicate that in a lab. So that's another significant possibility in terms of methane removal. The issue is with so many of these things is what is scalable, because what you can do in a lab is one thing, but what you do in the open climate is there's so many variables there that they still have quite a lot of work to do, but the work is really promising, I think. Flaring. So as I mentioned, I mean, just by flaring is converting methane into CO2, so you're reducing the challenge there, but flaring in itself is not a good thing. However, there is an organization that we filmed called Frost Methane, I think it is, and what they're doing is they're going around to a lot of the mom and pop oil wells and different places, disused mines, where the methane's just leaking, and it's not worth those people's time to cap that, or it's just too far out. A lot of these mom and pop wells are like a day's drive out. You get out there to find out, because they don't have a monitoring system. So anyway, what they've done is they've developed a portable flaring system that works with methane that's got high sulfur amounts or other kind of problems with it, and they're able to actually burn it off. So it's quite interesting. Blue carbon. Sorry, my wife's telling me to speed it up a bit, so I'm rambling. Blue carbon. So the ocean was the next project that we did in terms of how you can actually reduce CO2. Peter and other people have already discussed that, so I don't need to go into detail. And we certainly looked at the issues of whales and how we've just butchered the hell out of them. So there's no very little biological iron in the ocean. OIF is great, but it's still mineral iron. And it's a shame. If it's possible to get the whale population back up, then that biological iron is going to stay in the ocean a lot longer. This is Victor Schmedicek. I think he's going to be doing a talk, or he has done already. He's amazing. We hooked up with Victor in Bremerhaven in Germany. He's with the Alfred Wegener Institute. And he's been on 3 journeys already in the South Atlantic working on OIF. And he's had really amazing results. In fact, I think the last one that he did was a bit of a failure, which was a success because it showed him where it wasn't working. But yeah, this is taken from one of the ships that were in the South Atlantic. And again, this is satellite imagery that we put into the films of the dust clouds moving across from the Sahara, going across the Atlantic Ocean, and that just gives you an idea of the extent of material that's going across there. You know this guy. I hooked up with Peter in the Philippines. We were filming around the Pinatubo area. Where Peter's standing there is 25 feet higher than it would have been in 1990 when Pinatubo erupted. 25 feet of ash dropped on that area. And this is the crater, over 5 kilometers, around about 5 kilometers, cubic kilometers of material was ejected into the air, enough to certainly affect the temperature. I'm going to go on to that's the graph that I think Peter's showed that represents the dip in or the pause in global warming over a number of years. Again, there's lots of debates going on about this, and it's not about anyone being overly right in this. There's so many things still to explore on this. But one thing to take into account here is these are all different volcanic events that have happened since 1880 that are of a really large magnitude. And each time you can see that there's a dip in warming there. So there's obviously a significant connection there. That's Victor again. And Victor was involved in ocean iron fertilization, but a lot of his focus has been on ocean permaculture. And one of the things that we looked at is sargassum, which is a free-floating seaweed that is just choking up places. That's the downside, but the upside is that it's an amazing sequester of carbon. So how do you find the balance there? And even more important, I think, is what some of the people here have touched on, and that is the business of saving the climate. If there's a way of making money out of this, then it makes life a little bit easier. So we hooked up with a company, a number of companies, one in St. Kitts, which is Seafields, and they are collecting methane and then turning it into, beneficiating it into everything from vegan leather to emulsifiers, which combines waters and stuff with oils for cosmetics and stuff like that. I'm sorry?
They're collecting sargassum.
Oh, I'm sorry, yeah, they're collecting sargassum, and then the idea then is to bale it, the stuff that they're not using, and then drop that into the deep abyssal plain. This is in just north of Cancun in Mexico where we were filming. This is the sargassum coming ashore. They get paid by the hotels to clear all that stuff because it stinks, it rots, it basically suffocates a lot of the local shore life. After 12 hours, it starts releasing methane, which is a significant problem. So their business model is that they get paid by the hotel to reduce the nuisance factor, and then they process it in a factory. Another organization that we filmed with in the Philippines was the Climate Foundation, Brian von Herzen's organization. And what they're working on is, because of the warming of the water, there's a bit of a kind of a heat buffer that's stopping the nutrient-rich upwelling coming up to the surface. So what they're doing is working with the seaweeds on a platform that they build, and then they lower that in the evening to the about 200 feet to where there's a more nutrient-rich water, and then in the daytime it raises up again for photosynthesis to take place. The other good thing is that the Philippines is quite prone to hurricanes and, pretty drastic ones. So they just lower this 200 feet and then it's not affected by the prevailing weather and the catastrophes that happen. The built environment is a little bit different that we looked at because the first two subjects are on such grand scales that there isn't much that an individual can do. Whereas the built environment, there's a number of things that individuals can do. 37% of emissions come from construction. It's massive. And obviously concrete is in everything, it's in everywhere. It's the biggest man-made material on the planet. For every ton of CO2 that's made, there's a ton. Every ton of cement that's made, there's a ton of CO2. But it's complicated because, again, we're carbon life forms ourselves. Carbon is such a part of our life that you can't just treat it as a bandit. This is Brent Constance, and he's an amazing guy. He was in the medical field, and he developed a method of creating a calcium carbonate that you could mimic the structure of bone instead of putting metal pieces to bend fix bones back together again. But then he moved on to climate, and he's developed a method of removing CO2 at ambient temperatures. That's amazing, but the challenge with that is that it only really works with point source. So if he can get near a concentrated area, which is massive because his system's modular, so you could put his system at every gas-generating power station or electricity gas-based power station, take in that CO2 and create material for the building construction industry to make carbon negative and even carbon neutral cement. So we just filmed some of his lab rats there working away. This is his system in California. Green building, and obviously green building isn't just putting plants on car parks and stuff like that. We spent quite a bit of time working with different people, looking at alternatives to cement like hemp. This is a house that's being built. It's a wood structure, but it's being built with hempcrete, which is a combination of hemp and lime. It's amazing stuff. It's carbon negative, and it continues to actually absorb small amounts of carbon through its lifetime. And it also deals with moisture better than concrete or anything else. It's quite amazing stuff. This is the finished house that they'd built, and it's all hemp, this house. This is a company in Idaho. This guy on a skateboard has developed quite an empire out of using hemp for all kinds of materials. They make breeze blocks and they make insulation that isn't, doesn't get into your lungs and create all kinds of problems. This is a system here which is using algae, and they make these breeze blocks out of algae. These are the blocks that they made, and they to make it, they put the algae in these tanks and use UV light, and it's pretty incredible. And the load bearing on these rocks, on these stones, is the same as concrete. And they're doing a lot of stuff at the moment. Just a couple of notes that we put in there, that human emissions generally, 40.7 billion tons, 23.8 billion tons gets removed by nature, but we're still stuck with about 16.9 billion tons deficit annually. So when you talk about putting $1 billion into a direct air capture system that can take down 500,000 tons of CO2, it's a drop in the ocean. But as I say to some people, maybe we're at the Apollo stage or the Gemini stage, but we've got to get to we're at the Mercury or Gemini, but we've got to get to the Apollo stage. So it's all of these are steps along the way. Rock weathering, that's another consideration, that you look at a mountain and the exposed area over geological time affects the climate significantly. But in terms of our lifetime and in terms of our immediate needs, it's not good enough. But each time a rock breaks down, the surface area increases significantly. So an organization that we filmed in British Columbia in Vancouver, ARCA, are working with mine tailings, slag, the residue from digging up nickel. And nickel is being used primarily for batteries, and that need is going to be multiplied 20-fold over the next 10 years. So what they do is they've actually found a way of accelerating the rock weathering process to absorb carbon. And their funding model is connecting with organizations like Rio Tinto, Barlow Rand, who make a mess. They dig up stuff and they have all this material on the surface. And I mean, this is an open cast nickel mine. It's horrendous. So yeah, removing carbon and direct air capture. Humanity built its first submarine in 1859, and it could stay submerged for 2 hours. It had a short life because he crashed it, not because the system wasn't working. And he was using basically a CO2 scrubber, which is not too different from what modern submarines use or up in the space station. So why can't we do that atmospherically? Why can't we just take the scrubbing system out into the open and solve the problem that way? But it's all about scale, and all of these issues that we filmed are about, is it permanent, is it scalable, and can it be financed? So we went to Iceland, Climeworks, and they kind of cheat a little bit because they're using geothermal energy, which is free. So it's not a big energy expense for them to work at direct air capture. And what you see here is a is 2 units on top of each other, and they're about the size of a shipping container, and that's the idea. They're modules, so you can just keep multiplying them. I think they could remove 50,000 tons of CO2 a year, which is absolutely nothing. They've now built another one, which is 4 times the size, but it's still small amounts, really. And then there's a place in Texas, Stratos, that's being put together at the moment, and at capacity that'll be able to hold 500,000 tons. But 500,000 compared to a deficit each year of 16.9 is very little. This here is we filmed about biochar. Biochar is basically taking materials and heating it without putting it in connection with oxygen, so you're not creating carbon dioxide, but it takes energy to actually heat that. So what they do is they take human waste, wet waste, they put it through this system, they take the methane out of that to heat the material to a point where it becomes biochar, which is basically a charcoal that hasn't been burnt with oxygen. And what they're doing with that is that they don't get carbon credits at all. Their funding model is providing a service to Redwood, California, to remove the wet waste, the wet sewage, and then they make building material aggregate like this, which again is load bearing, and it's being used in construction. They're also using the biochar as a printer feed for 3D printing, and also for the dye stock to get rid of carbon black. So ecosystem restoration, that was the 4th film, and at the end of the day, nature's the only really big game in town at the moment. And as far as trees are concerned, as far as old-growth forests, it's massive. You compare old-growth forests' ability to absorb carbon compared to new forests that are being put up by logging and so forth, and it's really minimal in comparison. We then looked at the prairie situation and looked back in history to the Dust Bowl, which was in the 1930s, where we replaced the bison with cattle. We overgrazed it, we overused it, and over a period of 9 years, eventually we ended up with the Dust Bowl, and it was a catastrophe. And it's a pity that memories are short. You know, we've got short memories in terms of the wars that we've been through, and we've got short memories in terms of catastrophes like the Dust Bowl. And this was a common scene. We used this in the film, this video of people in this town in the Midwest, just trying to get by in life and basically abandoning it. We then dealt over in China, in Beijing, with John Liu, who documented the Loess Plateau, the shifting of soils. And basically, Loess is a deposit left from shifting glaciers. It's like a glacial till. It's really fine stuff. The area that we were talking about, the Loess Plateau, is about the size of Texas, I think. It's enormous, absolutely enormous. And what you can see here is that over generations, actually over 10,000 years, humanity just used that area and depleted it. And it was their Dust Bowl, but only on a far greater scale. So they set to work. They spent 9 years trying to figure out what to do. And then they implemented everything from not using agriculture on fields of greater than 30 degrees, not overgrazing it. They came up with some really basic principles, but they've restored the Loess Plateau now, and it's one of the biggest planetary success stories in terms of restoration. Yeah, it's just a tragic shot here of topsoil just being wasted and put into the atmosphere. We connected with, and releasing carbon, of course, Vala Clark, Austin. She's a rancher. I don't know if maybe you know. Yeah. Well, she basically worked with restoring the prairies. One thing we need to talk about we do talk about in the film is the fact that it's such a mistake to confuse intelligence with wisdom. And there's so much stuff that it's not that we're discovering it; it's relearning stuff. Basically, methods that we really should be using anyway. Yeah, don't treat soil like dirt. We worked on biochar as well, and basically biochar could remove approximately 0.44 gigatons up to about 2.6. That's the 0.44 gigatons is the minimum that's considered. We filmed in the the walnut groves in the Central Valley in California, where they were basically burning off all the trimmings from the trees, but now, because of the changes in the law, they have to use biochar because they can't release the carbon into the atmosphere. And hey, what, they take the biochar, put it into the soil, and as Hunter was talking about, carbon in the soil makes a massive difference. So it's increasing this significantly, the productivity. This is a group in the Philippines that we filmed making biochar. Biochar shouldn't really have open flames with it, but they use that to get it started, and then they suffocate it and just leave it to smolder. They take the biochar and then they use that to work on their crops, and they're getting some amazing results as well. I won't go into all the details and stuff. Ecosystem restoration, we went around a whole bunch of different farms using no nutrients at all, working with seaweeds, working with kelp, getting higher yields, and just improving life across the board. So that was the fourth and the last film that we put together. This has now started broadcasting on EarthX TV. It started on Monday, and we're now moving on to another project called the Climate Repair Cafe. Making 4 one-hour films, I don't recommend it. It's by the time you get halfway through, the science is already starting to change. So we're doing a bi-monthly 22-minute program that's going to be traveling around the world, connecting with different people, sharing what it is that they're doing, but sharing what they're actually doing and filming them doing it. So it's not just a litany of smart people talking to camera about what should be done. So yeah, that's it. Any questions?